For this problem, we're trying to find the maximum possible force per unit length that could be exerted on the wire by the Earth's magnetic field. So we have a wire, and we know that the force on a wire is equal to F magnetic is equal to L over C, and then I cross B bar. And so force per unit length is just divided by L. So we get I cross B bar divided by C. And so if I want to find the magnitude, then I find that the force per unit length is equal to I B bar sine of 90. I'm sorry, sine of theta, sine of, let me erase that. So sine of theta, we didn't get to the 90 quite yet. So sine of theta over C. So then 90, the force will be greatest when I is perpendicular to B bar. So that would be the maximum magnetic force on this wire, and so that if this theta is equal to 90, then this is equal to 1. So the maximum force is going to occur when I have I times B bar over C. So if this is the maximum magnetic force on this wire, then that the Earth's force is going to have to be at least this big in order to hold it to the ground. So this is if I think about my drawing, if this is my wire right here and current is going into the page and I point my fingers into the page, the force is going to be up. So that would be my force. So that means that my B field is going to have to be to the left. That's my B field, my B bar field. Okay, so I know that the maximum force due to gravity is going to equal force of magnetic force over L. So and so that's going to equal I is 300 amps times B bar is 15,000 newtons per coulomb divided by 3 times 10 to the 8th meters per second. Okay, and so when we calculate that, so F magnetic force per unit length is equal to 0.015, and then our units are going to be an amp is a coulomb per second. So I have a coulomb per second, and here I have newtons per coulomb, and here I have divided by meters per second. Okay, so my coulombs cancel, and my I'm going to have newton meters. My seconds cancel here because I have one on the denominator here, one on the denominator here, so I'm going to end up with newtons per meter, and that makes sense. So my force of gravity is going to have to be 0.015 newtons per meter, and that's going to be the max value, because if this wire isn't perpendicular to the B field, then the the gravitational field doesn't have to be the gravitational force doesn't have to be as strong, because the maximum force due to this magnetic field on this wire, on this current carrying wire, is this value here because they're perpendicular to each other.